Pearson and Spearman, when we can use Pearson correlation test?
The Pearson correlation test is used when for the parametric test.
This is a parametric test. Okay. So when
Yes.
can we apply this test?
We apply this test when we want to know the linear relationship between the data set.
Between two variables.
Yes.
Okay, so does this test give any assumption?
Can you repeat again?
Do you know any assumption that required for this test, or it doesn't need any assumption?
I think its assumption is that it must be normal distribution.
What must be normal distribution?
First is the data, the variable must be continuous, and the secondly, it must be a normal distribution.
Okay, the data, the variables needs to follow the normal distribution. Okay, yeah. So when we talk about the correlation between the variables, can you give me how many types of correlation? Do you understand what I mean?
Type negative.
Yes.
Negative and positive linear relationship.
Yes. When can we say it's negative correlation?
When the R is smaller than 0, and the positive is when the R is bigger than 0.
Okay, yeah, thank you. Yes. Nguyễn Hà Nhung.
Is negative, then
when we say there is a negative correlation between variables, so what does it mean, negative here? You don't know?
No, I don't know. Sorry.
Hồ Minh Nguyệt. Hồ Minh Nguyệt.
Yes, sir.
So can you explain what does it mean, a negative correlation?
So the negative correlation is mean that when the one is increase, the another is decrease. The another decrease.
Yes. When one variable increases, the other variable will decrease, right?
Yes.
Okay. So how about positive correlation?
The positive correlation is mean that the two sample is together increase.
So when one variable increases, the other will increase too, right?
Yes.
Okay, so yes, so we can say a negative correlation, or this variable is negatively correlated with the other variable. Okay, and positive correlation, we can also say that this variable is positively associated with the second variable. Okay, so you need to understand what is negative and what is a positive. Okay, yes. Okay. Yeah. So, last time we have already, I already give you the correlation coefficient R. Okay, so to do this kind of test, we will need to check the assumption about the normality of the data first. Okay, so if we can assume that the two variables follow the normal distribution, and then we can apply the Pearson correlation test. And for this kinds of tests, we need to calculate the correlation coefficient. Okay, so we already know this formula for correlation. And when we look at the R value, you can conclude about the negative or positive linear relationship. And you can also talk about the strength, okay, and direction. Not only the direction, negative or positive, that is the direction of the correlation. And the R value also gives you the strength of the correlation. It can be very strong, okay, if R close to 1. And it can be very weak if it's close to 0. If R is 0, it means there is no correlation totally, okay? So I give you also the coefficient values that can help you to talk about the strength of the linear relationship. It could be very strong, it could be moderately strong, or it could be fair or poor based on the values of R, okay? So you should know that. So when you do data analysis, when you do the report, you can make some conclusion about the data that you got. And this is the way to apply the formula. You will step by step find the calculate the components in the formula, and then you just apply it to calculate R. Okay, and we already did this exercise. Okay, and today we continue to talk about the Pearson correlation with the coefficient of determination. Okay, so if R is the correlation coefficient, and then we can take the square of R. Okay, this value R, and then you take the square, and the value of R square, we say that is a coefficient of determination. Okay, so you take note about this new term, coefficient of determination. It is R square. So what is the significance, or what is the meaning of coefficient of determination? Bùi Bích Ngọc.
Yes.
Okay, so what does the correlation of determination tell us? What information does the coefficient of determination give?
I'm sorry, I don't know the answer.
Yeah, you can look at the slide. The information on the slide. Okay, and you can read to know. Can you see the slide?
Yes.
Okay.
The coefficient of determination is R squared.
Yes.
And
and what information?
And the portion of variability in one variable that can be counted by variability in the second variable.
You understand that?
I don't understand a little bit.
You don't understand?
Yes.
Okay, so the coefficient of determination, it tells us the portion of variability in one variable that can be counted by the variability in the second variable. Okay, so you know that when we collect the data, it always exists the variability, okay, of the data set. And if we know the coefficient of determination, we can say how many percentages that the variability of this variable can be explained by the variability in the second variable. And when R square, the bigger R square, it means the second variable can explain the more probability that the second variable can explain for the variability of one variable. It could be a little bit difficult for you to understand at the beginning, but if we look at example, it can be easier for you. Okay, so let's take an example. For example, we are going to talk about the relationship between the depression and CGPA, the score, okay? The scientist is trying to find the correlation between the depression and the score. And they use the Pearson correlation test, and they get the R value. R is a correlation coefficient. It is minus 0.05. Okay, that is the R value that they obtain in the correlation test between the depression and the GPA score. So Đỗ Bích Ngọc.
I'm here.
Okay, so if you look at this value of R, what can you conclude about the correlation between the depression and CGPA?
So here is the negative correlation. So it means that the relationship between the depression and the CGPA is a negative linear relationship. It means that the increase of the depression leading to the decrease of the CGPA.
Okay, what else?
And we can conclude that when the student have higher depression, so that they can have the low score in the CGPA.
Okay, yes, so that is the first point that you can conclude about the correlation from the R value. What else can you conclude from this value? Can you think about another point that you can say?
So as I can see on the slides here is I have the R square value. So we can easily understand that the variability in the GPA score can be counted by depression, about 25%.
Okay, that is we'll talk about the coefficient of determination. Okay, but I still asking you about the R value. Okay, from this value. Okay.
Okay, the R value is equal to 0.05. So it have a poor strength of the linear, negative linear relationship.
Yes. Okay, so remember that the R value not only gives you the direction, negative or positive, but also gives you the idea about the strength. Okay?
Yes.
Yeah, so there are 2 points that you can talk about the correlation from the R value. So the first point here, you see the R is minus 0.05, is less than 0, is negative value. So you can say that So there is a negative correlation between the depression and the CRPI. But the second is, I'm sorry. Okay, so we are talking about the Pearson's correlation coefficient, the R value. So you can see here the R value is very small. It's very close to 0. So you can say that if the linear correlation exists, it's very poor. Okay, the correlation is very weak. And that is the 2 points that you can talk about the correlation from the Pearson R value. That is a negative correlation, and the correlation is very poor. Okay, so it's not really correlated to each other. Even that when the increase, there is increase in the depression, there is a decrease in GPA score, but it's very poor, not really correlated to each other. And then from the R value, you can calculate the coefficient of depression. So you take the square of R, you get R square equals 0.25. Okay, so Lê Trân Tuyết Mai.
Yes.
Okay, so from this, the value of R square, the coefficient of determination, what can you say?
We have the R square is equal 25%. I think that 25% of CGPA scores is affected by the depression, and 55%. The rest of 55% of variability is affected by the other factors.
Yeah, yes. So you can see here the R square will tell you how many percentages that one variable can be explained. The variability of one variable can be explained by the second variable. So here 0.25, the R square value, it means 25%, okay, of variability in the CRPA score can be accounted or can be explained by the depression. Okay, so it means the 25 is not high value. Okay, is low value. Only 25% of variability in CRPA can be explained by the depression. So it means that there are 75% left, remaining 75% of variability in CRPA score is affected or explained or accounted by other factors. The other factors, it can be the habits, motivation, or causes, or anything else can affect the score. So from this, you can see that also the strength of the correlation. Okay, when so from R value, it tells you the negative and the direction and the strength. The R square value, the coefficient of determination, it tells you in quantity. Okay, you can know how many percentages that one variable can be explained by the second variable. Okay, it gives you a number so that you know how many percentages of variability in one variable can be accounted or can be explained by the second variable. So the higher R square, okay, it means that one variable can be explained more the variability of the second variable. So because this correlation is weak, it's poor correlation, so the depression can explain only 25% of variability. So it means that if you want to find the factors or the correlation, the factors that can affect the score CRPA here, you need to also study other factors. Not depression is not the main factor that affects the score. there exist many other factors account 75%. Okay, so it helps you in studying, in trying to find the correlation and factors that can affect the variable that you are interested in. Okay, so you can, so from the R value, you can take the square of R. That is a coefficient of determination. So you remember the term coefficient of determination. So when R is 0.5, for example, so R square is 0.25. Oh, so that is, let me. .05. I think here I have a mistake. 0 minus 0.05 square is equal what? Is it correct here? Can you take the square of minus 0.05? Is it correct?
It's not correct.
Yeah, I see it's wrong here.
Yes.
It should be that like 0.0025, right?
Yes.
Yes. So it's correct here, but no one recognized. So it means only 0.25%, right? So the depression can explain only 0.25% variability in CGPA scores, very small value. Okay, so depression is not the factor that mainly affect the CGPA. So it remains how many percentage for other factors? What number should be here?
0. No.
No, not zero. What number?
99.75.
Yes, 99.75. Okay, so you see, it means other factors more important than depression can explain for the CGPA score. They account 99.75% of the variability of CGPA. Okay. Okay. Trịnh Sao Mai?
Yes.
Yeah, so when R is 0.5, what is coefficient of determination and what can you conclude?
R is 0.5, so the coefficient of determination is 0.25.
Yes.
In the R value, because it's positive here, so they have positive correlation. It means when one variable increase, the other will increase, and inverse. It's 0.5, so it's not really strong. They do not have strong correlation.
Yeah,
it's quite weak.
Weak, okay.
Yeah. And for the coefficient of determination is 0.25, so it means 25% of one variable will be affected by the other variable.
Yes.
And 75% will be depend on other factors.
Yes, 75% of variability in the set of one variable is accounted by other factors, okay?
Yes.
Yeah, it's correct. Nguyễn Thị Linh.
Yes.
Okay, so can you talk about the case that r equals 0.7?
If the R equal 0.7, there is a positive correlation. It means when a variable increase, the other variable will increase too. And because it equals 0.7, then the strength of linear relationship will be moderately strong. And the coefficient of determination equal 0.49. It means that 49% of variability of one variable can be counted by the second variable. And the 51% of the variability will be affected by the other factors.
Yeah, it's correct. So yes. So R is a 0.7. It is a positive. It tells you a positive correlation, moderately strong. Yes, and so it means when one variable increases, the second variable will increase too. Yes. So from R, you can calculate the coefficient of determination. That is R squared. R squared equals 0.49. So it means 49% of variability in one variable can be explained by the second variable. So there is the remaining 51% of variability in one variable is affected by other factors. Okay, so it means there exists other factors that affect the variable. Okay, so yeah, we continue to explain this example. Okay, you take 1 minute to read the example. Trần Lê Nam Khanh.
Yes.
Can you read the example?
A study was done to find the association between the mother's weight and their baby's birth weight. The following is the scatter diagram showing the relationship between the two variables. The coefficient of correlation is 1.452 and the coefficient of determination is 0.204.
Okay.
And yeah.
Okay, yeah. Now you can say about the correlation between the two variables. What are two variables in this case?
Two variables are positive.
No, what are the variables? Tell me what are the two variables in this?
Two variables here is the mother weight and baby's birth weight.
Yeah. Okay. Yes. Continue.
The correlation is positive and quite quick correlation.
Quick?
Quite quick.
What do you mean quick?
It means not too strong. Weak.
Weak. Okay.
and the coefficient of determination it means that 20% of the variety of baby birth weight is explained by the mother weight, and the remaining 80% of the variable can be accounted for another factors.
Yeah. Yes. So yes. So you see, the correlation test is very useful for you to talk about the correlation between the two variables. Okay. So in your opinion, what is a dependent variable and what is an independent variable in this case?
Baby birth weight is the dependent variable.
Okay.
And the mother weight is a dependent variable.
Mother weight is, sorry, can you repeat?
Independent variable.
Independent variable, yes. So mother weight is an independent variable, and baby's birth weight is a dependent variable. Okay. So the correlation coefficient R is 0.452. So yes, from this value you can say that the correlation is a positive correlation. Okay, so when the mother weight is increased, the baby's birth weight can be increased. But this correlation is not very strong. Okay, it's, you can say it's a bit weak correlation. You can see on the figure the data are the points. Okay, all the points are the real data, and the line tell you the trend of the correlation. It is a positive trend. Okay, but it's not very steep. Okay, so it's weak. Okay, it's weak correlation. And the points are very far from the line. Okay, so the linear correlation here is weak, but there is a trend. But you can say there is a trend that when the mother weight is increased, the baby's weight is increased too. Okay, and then you can calculate the coefficient of determination as square. In this case, it is 0.204. Okay, so it will tell you that how much variability that of the dependent variable can be explained by the independent variable. And in this case, the mother weight can explain only 20%, around 20% of variability of the baby, the birth weight. So there is a remaining 80%, okay, remaining 80% of variability of the baby birth weight is affected by other factors. So mother's weight is not important, not really, or not the main factor that affects the baby birth weight. Okay, so you can see the Pearson correlation, the coefficient of determination help you, is very useful for you, okay, to find out the relationship between the two variables and guide you. Okay, it is an important factor, or there exists another factors that we need to study more. Yeah. So we will talk about the correlation, but is it a causal relationship or not? What do you think about it? Trần Nam Khang. Trần Nam Khang. Can you hear me, Khang? Huh? You don't want to say anything? Trần Lê Nam Khanh.
Yes.
Okay, so I'm asking you, can the Pearson correlation test tell you the cause-effect relationship? In your opinion, okay, I'm asking your opinion.
Sorry, can you repeat again?
Okay, so we are talking about the correlation, and the Pearson correlation can tell you about the correlation between two variables. Okay, so can Pearson correlation test can tell you the cause effect relationship or the causal correlation. You understand that term?
What the causal means?
What causal mean? It means the causality. It means one variable is causes the factor that causes, like the independent variable is the main reason, or and it causes the second variable, which is the causal relationship. Or we can say the cause effect the relationship. The independent variable, it is the main reason, or it's the main cause of the dependent variable. Dependent variable is the effect, and the independent variable is the cause. You understand?
Not really.
Not really.
Yes, not really.
Okay, I will talk this term in Vietnamese. Quan hệ nguyên nhân kết quả. Liệu cái hệ số tương quan, cái mối quan hệ từ cái test Pearson test này có cho chúng ta biết cái mối quan hệ nguyên nhân kết quả, tiếng Anh là causality hay là cause effect relationship. Quan hệ nguyên nhân kết quả tức là gì? Tức là cái biến độc lập là nguyên nhân gây ra cái biến phụ thuộc đấy.
Wow.
Okay. So do you think that the Pearson correlation test can tell you about the causality relationship or cause-effect relationship between the independent variable and the dependent variable?
In my opinion, I think yes.
Yes. Why? So we can, it means we can conclude about cause-effect relationship.
Yes, I think so.
Without any others, anything else?
I think it's not.
You think it's not? Who is saying?
I'm here.
Okay, okay. So why don't you think it's a causal relationship? And to conclude about the cause-effect relationship, what should we do?
I think the factor of the mother weight is not directly affect the baby birth weight, and as we can see there is only 20% of the baby birth weight was determined by the mother weight. So we cannot conclude that the mother weight will affect the baby birth weight. So I think it's not have enough evidence to conclude that have a cause-effect relationship.
Yeah, in this case, yeah, in this example, the R value is small, okay? So it is a weak correlation between the two variables. So you can say that. But in another examples, the R value could be very high, okay? It can be 0.9, for example. For example, R is 0.9. So can you conclude about cause-effect relationship? Enough evidence from this test we can talk thus using this correlation test with the R value is 0.9. Can we say that it is a cause-effect relationship?
I think if it have about maybe absolutely 100%, so we maybe can conclude that they have the cause effect relationship. But when it only have the 95 or 99%, so it can be occur about 1 to 5% of it can affect by other factors.
Yeah, I'm asking you about cause-effect relationship is for all the cases of value. So for this case, it's not the cause. For that case, the independent is the cause. So it means the correlation test always used to talk about cause-effect relationship. In your opinion, it's not this case yes, another case no. It's not like you are understanding. If yes, it means in this case we can say, oh, this is the cause of that variable. In that case, it's not the cause. Other factor is the cause. So it means, so you agree that the correlation test can conclude about cause-effect relationship. Okay. According to your answers, I understand that you think that the Pearson correlation can conclude about cause-effect relationship, right?
Yes.
Yes, this case, yeah, there is a cause-effect relationship. That case is not. So if you can conclude too, it can be yes or no, but you can conclude about cause-effect relationship. In your opinion, is it correct? What I understand?
Yes, I think.
Yeah. Okay. So we will see if your understanding is correct or not. So, in fact, the correlation does not imply the causality. Remember that. We just find the correlation. Okay, there is a correlation, or there is not a correlation. The correlation is very strong. The correlation is medium, or the correlation is very poor. Okay, it is just about correlation, and the coefficient of determination will tell you how many percentage risk that one variable can explain for the variability of the other variable. Okay, just that. Okay, we don't have enough evidence to conclude about the causality, the cause-effect relationship if we use only the Pearson correlation. Remember that. We just can talk about the correlation, okay? Strong or weak or poor, okay? And causality, to demonstrate about the causality, it means we try to demonstrate that the variance in one variable can only due to the influence of the other variable. And we need to use controlled experiments. That's why you may, when you search on the internet to find the literature, you may find many studies that have control design. Okay, we need the control experiment to give evidence for the cause-effect relationship. Even when we find a really high correlation, it still does not give enough evidence to conclude about the cause-effect statement, but it can help us to predict. Okay, you can make a prediction, but you cannot sure. Okay, you cannot be sure that it is a cause-effect relationship, but it can guide you. Okay, when you find a really high correlation, it can make you some prediction, but to conclude about the cause-effect relationship, you need to do the controlled experiment, control design. Okay, you need to control, and you might find information about what is a control design. Okay, in this course we don't learn it, but I give you information. Okay, we need the controlled experiments, controlled design to establish about the cause-effect relationship. Okay, so it's really important to remember that the correlation test just give you the correlation. It doesn't mean the causality. It doesn't mean the cause-effect relationship, even when the correlation is very strong. Okay, pay attention about that. Okay, so we take a break. Okay, and then we back to again the lesson. Okay, so now we move to the second correlation test. It is a Spearman correlation coefficient. Okay. Đỗ Đoàn Thu Giang.
Yes.
Đỗ Đoàn Thu Giang. Okay,
Yes.
so can you tell me what you know about the Spearman correlation coefficient? When can we use that?
Spearman correlation is a non-parametric test. The Spearman correlation is when the data not normal distribution. Measure the trend of monotonic relationship between pair data.
Okay. Yes, so it is a non-parametric test. It is corresponding to the Spearman correlation. Okay, so when the data is normally distributed, you will apply the Spearman correlation to find out the correlation. But in case the data are not normally distributed, instead of using Pearson correlation, you will use the Spearman correlation coefficient test. Okay, so it is a non-parametric test, so we don't need assumption about the normal distribution. Okay, you don't need to check the normality for this test. So which test will be more powerful between the Pearson and Spearman correlation? Nguyễn Văn Giang.
Yes, hello.
Okay, can you hear me?
Yes, I can hear you. Can you hear me well?
Yes, I hear you very well. Okay, so I'm asking you between the Pearson and Spearman correlation test, which one is more powerful than the other?
Tiếng của em bị echo.
You cannot hear me, Giang?
I can hear you. Okay, so I'm not sure, but I think the Pearson is more powerful.
Pearson is more powerful. In your okay. Yes, it's correct. Okay, the parametric test is more powerful than the non-parametric test, and Pearson is a parametric test, so it is more powerful than the Spearman, the non-parametric test. So, what is the difference between the Pearson and Spearman test?
I only remember that the Pearson is a parametric test and the Spearman is a non-parametric test.
More detail about the difference between the two tests.
I remember that.
Okay. Yeah. So we will see more detail about Spearman, and then we can compare. Okay. So you know, Spearman is a non-parametric test. It used when the data are not normally distributed, and here I write it measures the strength of monotonic relationship between paired data. Okay, so in Pearson, so what does the Pearson tell you? What kind of relationship does Pearson correlation test tell you? You remember? What kind of relationship that Pearson correlation test tell you? Vân Giang, you remember?
I'm not sure I know what it. I don't remember much because usually I will reread the slide.
Okay. Okay. So Nguyễn Văn Anh, do you know what kind of relationship that Pearson correlation test tell you?
The Pearson can tell us about the linear correlation between two variables.
Yes. Pearson correlation test tell you the linear correlation, okay, between the dependent and independent variable. And here the Spearman correlation tells you the monotonic, okay, so you remember the term. Pearson is linear relationship. Spearman tells you the monotonic relationship. So anyone knows what is a monotonic relationship? Have you ever heard about this term? Or you can search about it, okay, and then you tell me, okay, monotonic relationship. Think about it and give me some ideas about the monotonic relationship. Nguyễn Phương Anh, do you know?
Maybe I can guess. So the monotonic relationship means that when a variable is increased, another variable is also increased and vice versa.
So it means
they have the same directions.
The same direction? It means always one increase, the other increases. Only that? Always that?
And when one is decreased, another is also decreased.
So it's like a positive correlation, right? When one is increased, the other also increase. That is a positive, right? So if you explain like that, it means the monotonic relationship is always a positive correlation. Is it correct?
But when it is positive, which means it's like increase in a linear, so it means it's like a more constant rate. But when it's monotonic, it doesn't need to follow the linear.
Yeah, it's not linear, okay? But you explain that when one increases, the other increases. Are there any other cases for monotonic? Yeah, you are partly right. But continue, okay? Continue. Yeah, you tell me one case when one variable increase, the other also increase too. That is one case, but it's not all about the monotonic relationship. What is a monotonic? What is a monotonic relationship? Quân Anh, do you know? Can you guess?
Monotonic.
Yeah.
I don't even know about the word.
You have heard about this? You have never before heard about it?
No, I'm sorry, but I have never learned about this.
Okay, yes. So monotonic, it talk about the not linear. Okay. First is not linear is a special case of monotonic relationship. Monotonic is it could be non-linear relationship, but it have a change. It could be positive change, or it could be a negative change too. Okay, so Phương Anh, you just talk about the positive change, or we can say monotonically increasing change. When x variable increases, y variable will increase too. That is monotonically increasing. But it's just one case. The second case is monotonically decreasing. It means it's like the negative correlation. So when x variable increases, the y variable decreases. Okay, we say so that is the two cases of monotonic relationship. Okay, it's not linear relationship. It's not a line. Okay, so when you draw a curve, it is a curve. It's not a line, but it has a trend, increasing trend or decreasing trend. And the last, you can see the figure, three figures. Okay, the last figure is not monotonic. You see, the last one. Why we say that the last one is not monotonic? Phạm Ngọc Hà.
Yes, I'm here.
Right? So why is the last case not monotonic?
So the last case is not the monotonic because I think because the direction of the curve is changed. It's not move in the one direction.
More detail. So more detail.
So at the first part it decreased, then it increased, and it decreased.
Okay,
so for the monotonic will move in one direction, increase or decrease, and the non-monotonic can be moved in increase or decrease.
Okay, yes. So when x increases, the y variable not always increase or decrease. Okay, sometimes it increases and sometimes it decreases. Yes. So we say it's not monotonic. Okay, so now you can imagine about the monotonic relationship. So the Spearman correlation, it will talk about the monotonic relationship. If we apply the Spearman correlation, we just talk about this relationship, but not the linear. Okay, we cannot conclude about the linear. Even when one variable increases, the other increase too. But it's not linear. We are not sure. We don't have enough evidence for the linear. But if you apply the Pearson correlation, you can say about the linear. You see the difference. Okay, so that's why Pearson correlation test is more powerful. The parametric test is more powerful than the non-parametric test. Okay, so Spearman. Sorry. Okay, yes, so I'm talking about the relationship between the Pearson and Spearman correlation that they tell you. So remember, in Pearson correlation test, you can conclude about the linear correlation. Okay, and in Spearman you cannot say linear relationship. You just can say about the trend, decreasing trend or increasing trend, and that is a monotonic relationship. Try to remember that. And like in Pearson correlation, in Spearman correlation test, you also try to find out the coefficient, the correlation coefficient. And in Spearman, we can use the letter RS, okay? That is the Spearman correlation coefficient. And it exactly the same as in the Pearson correlation. It always between -1 until 1. And you can also conclude about the strength of the correlation. Bùi Đức Huy.
Yes.
Okay, so
yes.
Can you talk about the strength of the correlation based on the value of Spearman correlation coefficient?
So for the correlation coefficient, it ranges from -1 to 1. The nearer the coefficient value to -1 or 1, we can say that it has a very strong correlation. And
what else?
From 0 to 0.19, we can say it has a very weak correlation. So so if our coefficient value is near to 0, it has a weak correlation. From 0.4 to 0.59, we say that it has a moderate moderate correlation.
Okay, yes. So based on the value of Spearman correlation, you can talk about the strength of the correlation test. Yes. And here is the formula that you can use to calculate the Spearman correlation coefficient. That is RS. So you see it's a big difference from the Pearson correlation. So here you see the D, the letter D. Okay, is so in which kinds of test you also see the letter D, if you still remember. Trần Nam Khang.
Yes. Yes, I'm here.
So here in this formula you see the letter D. Okay, so do you remember in what kind of test we also use the D? Also in the formula applied in what kind of test that we have learned? We use D too. Do you remember?
T-value. I think.
T-value? What kind of T-value?
I think I can guess, but I'm not really sure. I mean, see. I'm sorry, I don't know.
You don't know?
Yes, it is. Yeah.
The pair t-test?
The pair t-test. Yes, someone say it's correct. You remember pair t-test? Khang?
Kaya?
Pair t-test, do you know?
Yeah. We do learn it before, but I only remember a bit of that.
You are absent last time. I take note here. You are absent. Yeah. So maybe you don't know about it if you don't read again the lesson. Okay, so here we will use D. So what is D in this case? Trịnh Châu Mai.
Yes.
What is D?
D is the difference between two values in one pair?
Yeah, so in this case, you see we also have pair, okay, pair values. So we will apply D, that is a difference in rank, okay? Take note that it's not different in values of X and Y. It is the difference in rank, okay? So if you don't pay attention about it, you may got wrong result. You need to rank the data, and then you take the rank of X value minus the rank of Y value. Okay, so that is D. So it is easy to get wrong in this step. And N is a sample size or the number of pairs. Okay, sample size is the number of pairs, values X and Y in the selected samples. Okay, so, and then if you have D, you have N, it's easy to get CRS. Okay, so to do this kind of exercise, you can make a table. You can draw a table like that. Data 1 and data 2, okay, it's X and Y. Data 1, data 2, that is X and Y, dependent and independent variable. And then you rank, okay, the rank of Xi value, rank of data 1. You will write down the rank of all the value of the data 1. And the rank 2, that is a rank of the data 2, okay? You rank all the data, and then you will calculate D of each pair, rank 1 minus rank 2 in each pair. Okay, and the last column, you will take the square of D. You calculate the D square. Okay, so finally, you will apply the last row will be the sum. Normally the last row will be the sum up all the value in the column, and in this formula you see you will sum up all the D square. Okay, so you will sum up the D square column to get the sum, and then you just apply the formula, and it's easy. If you are careful in each step like that, you will get the correct result. Okay, so that is the way to calculate the RS, the Pearson correlation coefficient. Okay. Okay, so now you practice this one. You practice this exercise to find the RS. Đỗ Bích Ngọc, yes. Anyone have the same result?
Yes, I have the same result.
Okay. Cô Phạm Ngọc Hà, can you present the solution of this exercise?
Yes.
Okay. So do you have? Can you share the screen? Something on the screen?
Yes, I can.
Okay. Yeah. So I stop my screen.
So I use Excel to calculate the sum of D value.
Yeah, but can you share the screen first, because I don't see it.
Can you see it?
Yeah, I can see it now. Yeah.
So I will list the data sets, the English and the math. Then I rank them from the lowest value will be 1.
Okay.
Yes, and then I calculate the difference between two ranks. Then I calculate the square value of the D. Then I calculate the sum of square of D, and I found the sum is 54. Then I apply to the formula. And for the next step, I write down on my notebook.
Okay. Yeah.
Yeah.
Okay. So thank you.
Yeah.
Hồ Minh Nguyệt. Hồ Minh Nguyệt. Where is Hồ Minh Nguyệt? Oh, she's left. Bùi Bích Ngọc.
Yes.
Okay, so do you agree with what
Yes, I have the same question, the same answer with her.
Okay, do you get the same result of R?
Yes.
Yeah, so can you say something about
the RS equal 0.673, so it have a strong correlation.
It has strong correlation?
Yes, because it's in the more than 0.6 and less than 0.8, so it has strong correlation.
Yeah, what kind of correlation?
The Spearman correlation.
What kind of correlation? Spearman correlation test, that is a kind of test. Okay? Yeah, but what kind of correlation?
I think it's a monotonic increasing correlation.
So what are variables in this case?
The variables are the score in English and math.
Yes, the math scores and the English score. Yes. So that is a monotonically
increasing correlation.
Increasing correlation. Yes, is correct. Yeah. Thank you. Okay, so it is easy for this kind of test. Do you need to check normality in this case? Trần Lê Nam Khanh.
Em mặc định nó là non-normal luôn, em không check lại.
So do we need to check?
Yes.
Yes, we need to check.
Yes.
Why? You don't check. That you say me that we need to check. Do we need to check? Trần Ánh Xuân.
Yes.
What do you say?
I think we don't need to check the normality.
Why? Why?
I don't know the result. I don't know the reason.
You know the answer but don't know the reason? Nguyễn Ngọc Như Thùy, are you here now? Nguyễn Hà Nhung. Right, so do we need to check the normality of the data? Why? Cái này giống cái tương tự normal kia là nào không hiểu. Không biết thế nào. Nào lại không hiểu rồi. Lê Trần Tuyết Mai.
Yes, I'm here.
Okay, so do you think that we need to check the normality of the data?
I think that we don't need to check the normal distribution because the first, the Spearman is a non-parametric stat, so we don't have any assumption for this. And the second is because this is a non-parametric test, so it's the data, the data is not the variable is not it's not required is the interval or ratio variable. So I think that we don't need to check the normal distribution.
Nguyễn Thị Linh. Nguyễn Thị Linh.
Yes.
We agree.
Tức là thành ra tức là người ta
Yes,
phải tìm được cái đa dạng và đặc biệt ở Việt Nam là cái biên độ nó xảy ra ngay từ Nam nhiều nên là nó có những đại về mặt hình thái, đặc biệt là cái môi trường biển ấy, là cái môi trường.
Trần Lê Nam Khanh. Trần Lê Nam Khanh. Yes. Do you agree with mine?
I can hear her clearly.
You cannot hear what my said?
Yes, I can hear her.
Okay, so do you agree with the answer? You agree with her?
I say that I can hear her answer.
You cannot hear her answer, right? So now you give me the answer. Do we need to check the normality of the data?
I think no, because it's a non-parametric test.
What is a non-parametric test? What is a non-parametric test? Linh?
cả cái tập đấy là 10 mẫu chứ không phải là ở một vùng mà 10 mẫu. Trước đây thì chỉ nghe anh Kim nói thì hiểu rằng là ở cái vùng A là 3 mẫu, xong rồi lặp lại vùng B là 3 mẫu lặp lại cái đấy như ra. Bây giờ là các mẫu là cộng đấy là
Linh đang học cả hai cái một lúc rồi Linh.
Có những cái mà nếu như chỉ một em ở chỗ làm thôi, chỉ có hai trong buổi em ở chỗ làm chỉ có 2 mẫu thôi.
Chỗ làm á?
Mình vẫn làm mà. Vì lúc đấy là những cái này nó không có biến dạng, nó không biến dạng.
Yes.
Okay, can you give me the answer? Do we need to check the normality? Giang?
I don't have. I not check the normality.
Do you have? Do we need to check the normality of the data?
I think no.
You don't know?
I think we don't need to check the normality.
Why? Why?
Okay. Because the non-parametric test is not need to check the normality.
What else? What is the non-parametric test here? What is a non-parametric test here?
This is non-parametric test.
What is a non-parametric test in this case? Yep, can you explain?
Sorry, I can't explain.
I just want to answer like I still think that we still need to check the normality of the data.
Why?
Because before we discussed about comparison of Pearson correlation test and Spearman, and the Pearson test is considered stronger than the Spearman. So if the data we check turn out to be normally distributed, then we should prefer using the Pearson correlation test. For the case that we check that the data is not normally distributed, then we will use the Spearman correlation test.
Okay, yeah, thank you. Yes. Okay, so in general, okay, when you have a data set, okay, you can follow what Hiệp has said. You should check the normality of the data. If you want to use the Pearson correlation test or a parametric test, and in general, you need to check the normality. Okay, so it will help you to make sure that, okay, you can go ahead with the Pearson correlation test if the data follows the normal distribution. That is in general, and you prefer to use the Pearson correlation test or any parametric test. Okay, but in this case, the question asks us to calculate as the Spearman correlation coefficient. Okay, it means we are going to use the Spearman correlation coefficient. Okay, and you know that Spearman correlation coefficient is a non-parametric test. It doesn't require the normal distribution. Okay, so you don't need to check in this case. So it means when you want to use a non-parametric test and in more detail, the Spearman correlation coefficient, you don't need to check, okay, because it doesn't require the normality. You don't need to check. But in general, when you have a data set, and as he have said, you prefer to use the parametric test because it's more powerful, it's easier to make more conclusion. Okay, so you need to check. Okay, so it depends the situation. So remember that. And in this case, we are going to use a Spearman correlation, and it's non-parametric test, so we don't need to check in this case because it doesn't require the normality. It could be normal, it's fine, okay? It could be non-normal, it's fine too. We don't care, okay? But we know that Spearman is less powerful than Pearson. The non-parametric test is less powerful. So if you prefer to use the more powerful or the parametric test that we are familiar with, that we can give more significant conclusion, we need to check. So here is a solution for this kind of exercise, and your friend has shown you the correct answer for this kind of exercise, that we make a table like that. Okay, you will write down the first two columns as a data set of the two variables, and the two variable here is a math and English, and the next two columns is the ranking of the two variables. You can from smallest to highest or highest to smallest, up to you, okay? But it's we are familiar with the ranking from the smallest to highest, okay? And you need to rank correctly, okay? Correctly all the values in the two variables. So we'll have rank of English score, rank of math score, okay? And the next column is a D. D is the difference between the ranks in each pair. So it's easy to calculate it. And the last column is a D square, okay? So you take square of the D column, and then you sum up all the D, because in the formula you need the sum of D square, okay? So you sum up all the D, and it's 54 is correct, yes, that is correctly, and then you will calculate the RS, okay? It's easy, this step, and it's around 0.67, okay? Yes, and you can conclude it to the Spearman correlation. So when you conclude it, you cannot say a linear relationship, okay? You just say there is a correlation here, or more detailed monotonically increasing correlation between the math and the English score, and it's quite strong based on the value of RS, and you can say this correlation is quite strong, okay? So it gives you the direction and the strength of the correlation, but you don't know about the linear relationship, okay? You just know there is an increasing trend between the two variables. So now can you make a complete comparison between the Spearman and Pearson correlation, a complete comparison? Okay. Nguyễn Văn Anh.
Yes, yeah, I'm here.
Okay, now can you make a comparison, a complete comparison between the two kinds of tests, correlation tests, Pearson and Spearman?
Yes. First of all, Pearson correlation apply to normally distribution data, and Pearson correlation does not require normality. The Pearson correlation can tell us about the linear relationship, but the Spearman correlation just tells us about the trend the Pearson correlation apply for interval or ratio variables, and the Spearman correlation can apply for interval ratio or even ordinal variable. Can you hear me?
Yes, I can hear you. What else?
In Pearson correlation, we need to check the normality before we calculate. But the Spearman correlation, we don't need to check the normality.
Yes. Okay. What else? Anything else?
In Pearson correlation, we have two coefficient. Is one is correlation coefficient is R, and the other is coefficient of determination of square. And in Spearman correlation, the coefficient, there's only one coefficient, and it's calculated on the rank of the data.
Okay. How about the relationship? Did you talk about the relationship?
In Pearson test, the correlation between variables is linear. It's linear correlation. But in Spearman correlation test, the relationship is a monotonic relationship.
Yeah. Okay. Yes. So it's quite good. The answer. Okay. When I give you very good answer for the comparison between the two types of tests. So you should, from now on, okay, so now you have a statistical tool to find the correlation between the two variables, and you should remember the difference between these two types of tests so that you can apply it well and interpret the result better. So for Pearson correlation, it needs the normal distribution assumption. So to use that, you need to check the normality of the data. Okay, always you need to check. If the data does not follow the normal distribution, you cannot use the Pearson correlation test. And when the data are not normally distributed, you have to use the Spearman correlation if you want to find out the correlation between the two variables. But in case you want to jump up to the Spearman correlation, you want to use that, okay? You don't want even any case, so you don't need to check the normality. If you prefer to use a Spearman correlation, it does not require the normality of the data. And the Pearson correlation, it tells you the linear relationship, okay? The linear relationship. But in Spearman, the relationship cannot be linear. It can be not linear. It can be non-linear, okay? It can be linear or non-linear. We don't know. We know, and we can say that is a monotonic relationship. It could be decreasing or increasing monotonically. But we are not sure about the linear relationship. And about the variables in the Pearson correlation, you should remember that The variable need to be interval or ratio and continuous variable. But for Spearman, any kind of variable, interval or ratio or even ordinal variable can be applied for Spearman. Okay, and can you see in the formula we use the ranking. Okay, we rank the data and find the difference between different pairs to calculate the Spearman. And both these two types of correlation test, they don't give you the evidence for the causality. You have to know that. It does not tell you the cause-effect relationship. That is what I want to focus and want you to know. Okay, so in the future, when you analyze the data, the correlation, if you find a very, very strong correlation between the two variables, it does not mean that it's a cause-effect relationship. Okay, you cannot conclude. You still just can say that yes, there is strong correlation, but not the causality. Okay, for the cause-effect relationship, we have to make more experiments that is a controlled experiments, a controlled design to give evidence for the cause-effect relationship. Okay, so you have a very useful tool, statistical tool, and you understand the nature of this statistical test for you to apply when you analyze the data. Okay, so we stop here today for the lesson, and we continue the next time. Okay. So goodbye today.
Yes, goodbye, teacher.
Bye.
Yeah.